In this video, I'm going to talk to you about magnetic force, and these are going to be our objectives. We are going to derive the equation for finding the force on a moving charge and on a parallel wires or between two parallel wires. We are also going to use the left-hand rule to determine the direction of the force in relation to the current and the magnetic field direction. Okay, then we are also going to describe and explain the operation of an electric motor. This is one objective, but you are going to do them yourself. Magnetic forces on charges. By this time, you should know, if you've watched the earlier videos, you should be you should show appreciation for the fact that a moving charge creates magnetic field around itself, and that magnetic field exerts forces on another magnet or another magnetic material. So if there are two charges moving, then they will exert forces on themselves because they will be creating magnetic fields around them. You should also recall Coulomb's law, which states that there is a force between two charges that are separated by some distance. And if we should have a charge Q that is creating a field, the field can be calculated using this one, which represents the electric field strength. What is here represents the electric field strength. Then we can calculate the force this field strength exerts on another charge Q by simply multiplying it by the field strength, and that will give us the force between the two charges. Analogous to that is what we have if there are two charges that are moving. So this charge is creating a magnetic field that can be calculated using this expression, and that will give us this. We can cross multiply it by another charge that is also moving. This is the charge, and it is moving with this velocity. So this whole thing creates another magnetic field. And if this magnetic field interacts with this magnetic field, there will be a force between the two charges. So we can simplify the whole equation as the magnetic field of the big charge Q. This is the magnetic field cross multiplied by the velocity of the second charge, small q, and we multiply everything together and we get a force that is being exerted between the charges creating the field. Okay, so we can extend this idea to obtain the force that is being exerted between two parallel wires. Now, the second charge that is moving within the field of the first charge, the capital Q, if we take this one alone, then we can convert it to another expression. That's, we know the velocity to be the distance L divided by time. If we make time to become the denominator of the small charge, then that will represent the current of the second charge, leaving the length of the wire alone here. So instead of this, we can replace the whole expression here with this expression here. Okay, so for the force between two charges that are moving, we can replace it with this. In other words, if there is a charge that is moving in the magnetic field, we can calculate the force that will be exerted on that charge or that current with we can use this expression to calculate that force acting on that charge or on that current. Assuming the magnetic field is created by a long straight wire, then this magnetic field can be calculated simply by using this expression here, and the whole expression for the force on the current bearing wire can be written as this. So if we have two wires, then the force between them will be the current in one of them multiplied by the current in the other one, multiplied by their respective length and the other factors that are included in the expression. Okay, so this is the basis for the operation of an electric motor. If we allow current to flow through the wires, then we'll be able to calculate the force that is acting on the wires. If the wires are in a magnetic field, and so here we have a magnetic field, and these are the wires that are rotating in the magnetic field. We allow current to flow through it, and it will cause the two sides of the wire to rotate. I want you to read about the electric motor and convince yourself. If there is anything you don't understand, you let me